All right, I think we are good to start with today's webinar. So again, a warm welcome to everyone, and thanks a lot for joining in today's fraud analytics webinar. We will be discussing a couple of predictive modeling techniques as well as rule-based mechanisms in order to detect fraud, and how can we establish different use cases, or basically how we can go ahead and analyze fraud cases, especially with the help of the SAS software. So we are going to work with the newer platform, which is the Wire platform. And before we begin the session, just a quick introduction about who I am. So I'm Ashwini Reddy. I'm currently based out of a city by the name of Mumbai in India. Um, I have been associated with SAS for directly as well as indirectly for about 7 odd years right now. And some of the things that I look at in terms of the education side is relating to analytics across healthcare and life sciences, risk management, as well as either fraud or anti-money laundering. A humble request to the participants to please not annotate my screen. So let me just change that. Yeah. All right, thanks a lot for this. So before we could begin with the session, I just want to tell you about what's going to be the agenda for today. You can also, since I'm based out of Mumbai and India, the agenda or the timings that have been written down is in terms of the Indian Standard Time. In case if you're not from India, you have joined it from any other country, which would possibly be the case, I request you to just time the session according to the duration. So the first 30 minutes of the session, we are going to talk about a basic introduction. And in the introduction, we are not just going to limit ourselves in trying to understanding what is it that we would want to do under fraud detection, but then we are just going to look at the overall usage of the SAS software across the analytics lifecycle. We are also going to talk about how different solutions for different domains have been mapped or built over the analytics lifecycle of the SAS software. So the focus of the introduction is going to be more on the Wire platform, which is a newer cloud-based platform that we have with us. So in case if any of y'all are familiar with Wire, that's wonderful. In case if any of y'all are familiar with the older version of SAS, which is any of the versions of the 9X platform, then this you can consider it to be a new learning for you. And those of y'all who are unaware about what the SAS software can do, then this is a wonderful starting point or a wonderful introduction to a complete understanding as to what is it that you can do under the analytics lifecycle with the help of the SAS platform. And we're going to use very specific use cases and specific examples relating to fraud detection. Following the introduction, we are then going to move on to talk about the anomaly detection methods, which is a very common approach to identifying fraud behavior. And here we are going to use unsupervised unsupervised learning techniques rather, in order to understand identification of fraud cases. Right, so that's something that we are going to do with one of our tools, which is known as Model Studio, which is a point and click application. And you have different mechanisms, such as one of the mechanisms that we're going to talk about a little bit more in detail would be the SVDD, which stands for the Support Vector Data Descriptions. So that's one algorithm that we are going to look at under the anomaly detection method. We are then going to take a break, a nice 15 to 20 minutes break. So I have purposely kept the break to be a little longer in case if we end up taking a little bit more time, then the break time can be reduced to about 15 minutes. Otherwise, if we are good in the duration, then we end up keeping the break of 20 minutes itself. In the break time, you also will get an opportunity to put down any kind of questions that you have relating to what we would have discussed in the first 1 hour in the chat window. And the moment we regroup after the break, we are then going to take up those questions. I'm going to help you out with details if possible, in case if I wouldn't be the best person to answer your questions, and I would obviously try and help you in redirecting you to maybe some of the support websites or some of the reference material links that we have at our end at the SAS SAS's end. We are then going to move on to a semi-supervised learning technique in order to work with fraud detection again. And one of the reasons why we are going to take a semi-supervised learning technique is, for obvious reasons, a number of fraud cases would be a very small proportion or a very rare instant as compared to the entire volume of transactions that might be carried out on a day-to-day basis. Once when we are done with that, we're going to spend a little bit more time in terms of trying to understand how anti-money laundering works and how you have different rule-based systems. We are not going to look at the solution that we have at our end, but then I'm just going to give you an introduction in terms of how you can write SAS code to design those different rules in order to flag transactions that could be fraudulent or not. Finally, we would have a dedicated 20 minutes for Q&A, more of an interaction. If there's something that you want to discuss with me, then that's something that we are going to do in the last 20 minutes of the session. And we've got a 30-minute slot for the wrap up where I would be giving information in terms of different learning subscriptions, different ways in which you can access a SaaS platform, as well as certain regional contact information if you would want to enhance either your team's learning skills or you want to enhance your learning skills relating to the entire area of fraud analytics, as well as the different solutions that we have. So that's going to be the agenda for today. I just want to take a minute or two here before I continue. I would want to try and understand if there are any expectations that any of you all have from today's webinar. So we are going to spend 4 hours with each other. So I do not want it to be one-sided. So if at all, if any of you all do have any expectations that probably I might not have captured as a part of the agenda, I would request you to please either unmute and ask, or you could also just type it down in the chat window, and I shall try my best in order to accommodate your expectations. So yes, I'm just giving you all about a minute or two. Please feel free to unmute and give us your introduction, tell us about your expectation from the webinar, or you could also take the next 1 or 2 minutes to type it down in the chat window. Yeah, so over to you. I'll just go ahead and stop sharing my screen for now. All right. I don't seem to be getting any response there. So we are good to begin with our webinar for today. But again, just because, I said take the next 1 or 2 minutes in terms of typing down something in the chat window or unmute and speaking, not necessarily, you kind of have to limit yourself to that time. Even during the session, if you definitely want to share something with us, please feel free to go ahead and raise your hand, or you could also just type it down in the chat window. All right, so we are going to start off. So like I said, we are going to start off with the first part, which is in terms of just a basic introduction to the SAS setup. Okay. Arrange my screen. Yeah. So when you look about, or the moment you talk about analytics software out there, there can be multiple different brands that exist in the market. So 3 major brands that you would very commonly find from a usage perspective would be Python, R, and SAS. So Python and R are more of the open source languages. You do have an integration of Python and R within SAS as well. But when you talk about SAS, SAS is not just limiting itself to working with, just maybe cleaning the data or creating analytical base tables and then subsequently looking at how you would want to build your predictive models or your machine learning models. It's just not limiting itself to only that activity. SAS allows you to take your entire analysis and bring it into a picture in terms of model operation. So in case if you would want to take certain real-time decisions, if case if you want to take this analysis and deploy it onto a real-time setup onto the ground, such that your end users can pick up the analysis, utilize it, and then understand how you're supposed to go about with a particular problem statement. So SAS allows you to look at that aspect as well, right? So you have three main areas onto the SAS platform, which is the data operations. It all would be relating to the kind of question that you ask your data. It was going to help you in building analytical base tables. It's going to help you in data pre-processing activities that you need from a predictive modeling or a machine learning standpoint. Following that, you have the entire AI side as well, which is now coming up onto SAS. And then subsequently, all the kind of models that you build, you can also look at the model operations, the model governance, the model retraining, and ensuring that you retrain your models, you retrain your predictive models in order to answer a question according to the changing needs of time. So across the entire analytics life cycle, especially when it comes to fraud analytics, there have been a lot of customers in SAS, not just in India, but spread across all over the world. And you can get a lot of the customer success stories that utilize SAS for fraud detection specifically. Onto this link, which is www.sas.com. Within there, you're looking at the solutions framework, and there you have the fraud and the security intelligence. Right. So these are just some of the details that I have put down here onto the slide, and here you can see that there is one particular bank, which is the DKB Bank, that uses a solution that's offered by SAS that's built over the analytics lifecycle by the name of SAS anti-money laundering and SAS detection and investigation in order to identify fraudulent transactions. Right. Similarly, you also have Lance Bankin, you have Access Financial Services, you have the Department of Public Social Services in Los Angeles. It also uses SAS software in order to detect fraud. If you're talking about some of the leading banks in India, so if you're looking at HDFC, or if you're looking at Axis Bank, IndusInd, or to name some of the other few would be Standard Chartered, Barclays. If you're looking at all of these different brands, or the big brands, or the noted brands, or the commonly heard brands under banking and financial services, all of them, or rather most of them, have been the SAS customer since years on end. And they use not just the analytics lifecycle based tools, but then they also use different solutions in order to work with fraud detection, analysis, as well as reporting. Now, one of the points that you might think about is, why does SAS have a solution that works with fraud detection? And the very simple, straightforward answer to this is that a lot of regulating agencies that you have across different across different countries have a mandate or have a requirement, or one of their clause says that you have to report any kind of fraudulent transactions that your customers are carrying out. Right now, if that's the kind of regulatory requirement that you end up looking at, you do have different solutions that SAS offers, which is not just going to do the analysis part to you, for you, but then it's also going to take the analysis. It is going to marry it to the reporting template that your regulatory agency requires, and then create those corresponding reports, right? So if I just limit myself to the usage of the analytics lifecycle, there's not a lot, or the end-to-end process is something that I would not be able to achieve. But the moment I embed the moment I put up a solution framework on top of it, it becomes easier for me to just achieve the entire process. Right. So moving on, the moment you talk about the analytics lifecycle, you have 7 different steps that you would carry out as a data scientist or as an analyst in trying to understand the problem statement and also finding solution for the problem statement. So the starting point of it is you would ask a lot of questions in terms of what is the problem statement that you end up looking at, right? So here, if I have a customer which is going to walk up to me and tell me saying that I want to limit uh, the false positives, or I want to limit the false negatives that I end up getting when I try to manage fraud in my organization, right? So my problem statement here then becomes something like, okay, could you please help me out in trying to detect fraudulent transactions or fraudulent scenarios? Now, the moment this question comes up, you start asking, or the moment this problem statement gets identified, you as an analyst, or you as a data scientist, or you for that matter as a project manager as well, you start asking a lot of questions in terms of, are you just looking at transactions that could be fraudulent in nature? And if the answer to that would turn out to be yes, then how do you understand that a particular transaction would be fraudulent for your particular geography? Right now, across different geographies, there's a very common thing which is known as structuring. And as a end user, me as a customer of a particular bank, if I have to deposit some money in my account, there would be a particular threshold beyond which I would also have to declare the source of income for that cash. I would also have to give in my personal identifying details, and there would be certain regulations or rules that would be attached to that. However, if I deposit cash amounts lesser than that particular threshold, the source of income of that corresponding amount doesn't really come into the picture. It's not a necessary ask from the bank's end. So, certain customers who deal heavily in cash transactions, there could be a possibility in order to avoid those questions that they are asked in terms of declaration of a source of income, might structure the deposits across different bank accounts within that same bank, or might also split it across different particular time periods. Right, so trying to understand the nature of a fraudulent transaction, how a bank or how a financial service would determine what is a fraudulent transaction. On the basis of those questions that you as an analyst would ask the business, you then start looking at preparing your analytical base table to contain all of that information. Now, once when you have the data with you, once when you pre-process your data in order to handle certain anomalies in the data, or in order to handle certain missingness of information or partial information, once when you complete with all of those pre-processing activities, you then start looking at exploring your data, trying to understand more from it, and then you decide as to, on the basis of your exploration, you then decide which corresponding modeling technique you would want to use. Right now, that modeling technique could be either an unsupervised learning mechanism, it can be a supervised learning mechanism, or it could also be a combination of supervised with unsupervised that ends up getting into an area of semi-supervised learning. Once when you do end up having a model that could efficiently, not necessary 100%, a not necessarily accurate to the dot, but then efficiently identify fraudulent transactions, you then would want to start working on implementing that corresponding model such that the team that you have on the ground can then act upon the analysis and evaluate the model performance across a specific time period. So this entire 7 steps that you would carry out for a very generic business use case under the analytics lifecycle is mapped through to a 3-step version on SAS. So you have specific tools that's going to allow you to prepare data, and on the basis of the questions that you have asked, which is at the end resulting looking at the creation of an analytical base table, like I said earlier. Once when you have that table ready, you then get on to the discovery phase where you map the explore and the modeling aspects. And then subsequently, you're looking at the deployment phase where you have the acting, the implementing, as well as evaluating the model performance across a period of time. So if I have to just show you in terms of how do these 3 steps look onto the SAS via platform is So here I'm just using a demo instance of the SAS Wire platform that I have at my end. And onto the left hand side, I have a hamburger icon or a list of applications. So if I get in here, the analytics lifecycle tools that I can use to perform the three different steps is very easily accessible by the kind of action that you would want to perform, right? So when you talk about the creation of analytical base tables, then first you would need to bring in that data from somewhere, from an existing source system. So you then start talking about managing that source data. And then when you would want to create your analytical base table, you get into preparing the data. Once when I have that data ready with me, I then start moving on to exploring or visualizing the data. I then start building my predictive models. And once when I have a particular model that I would want to use, I then look at the next part, which is incorporating certain decisions in it, as well as ensuring that the model performance has been governed from time to time. Right. So that's something that we end up doing with the help of building decisions as well as managing models. Now, while we work with these different actions, there could be multiple objects that you create, there can be multiple tables that you use, there can be multiple reports that you would want to share with your colleagues within the organization. So in order to allow you to perform that sharing in a seamless manner from within the SAS interface itself, you have the next action which is available to you relating to share and collaborate. And subsequently, there are a lot of activities that you can do via point and click, and then there would be some of the activities or some nitty-gritties or very specific actions that you might not have a direct point and click option available within the SAS platform. Now, for some of those tasks or for some of those actions, you would want to design the SAS code by yourself. And in order to work on that, you have the action that you end up using, which is developing SAS code. Now, each of these actions access different tools onto the SAS Wire platform. So if I use preparing data or manage data, I get into something known as a data studio. If I use explore and visualize, then I get into another tool known as visual analytics. If I work with predictive models or machine learning models, then I end up utilizing a tool which is Model Studio via building models. If I want to manage my different models or build decisions, then it's a combination of intelligent decisioning as a tool as well as model manager. And subsequently, when you talk about developing SAS code, you end up using the very traditional setup of SAS Studio. And over and above this, like I said, if you would want to share information across two different colleagues across different areas of your organization within the SAS setup itself, then you use share and collaborate, which is going to take you to a tool known as SAS Drive. Right. So as a part of my homepage itself, the moment I log in to SAS Wire platform that I have, it takes me to the SAS Drive page, like you can see here. And there are different lists or different tabs of different activities that I would have performed and all the objects that end up getting listed down. So these could be objects that I myself have created. These could be objects that somebody else within my organization could have created, or it could be also certain objects that are private but have been explicitly shared with me, right? So this is a starting point. The SAS drive becomes a starting point in order for you to work with different aspects under the analytics lifecycle. In our session today, we are going to talk about writing a little bit of code in order to identify fraudulent cases as well as to explore the data that we would be working with for fraud detection. And second thing that we are also going to do is we are going to use Model Studio, which is a point and click application in order to perform either semi-supervised learning to understand fraud cases or even an unsupervised learning mechanism. Right, so those are the two examples that we are going to work with. And we are also going to look at how do we configure rules, or how do we write down rules in order to meet a specific scenario, which is going to be very common the moment you start talking about anti-money laundering. So just a little bit more on the Wire platform. So you have the analytics lifecycle, which is integrated either within SAS Wire or any of the SAS 9X versions of the different platforms that we've had in the past. Now, it just does not stop at the analytics lifecycle based tools, but over and above this, you have a lot of solutions and capabilities that have been positioned in order to show you an end-to-end process, or in order to automate your end-to-end activities relating to a specific domain or a specific problem statement. Right. So the moment you talk about uh, say, let's stick to fraud detection itself. The moment you talk about security and intelligence, you've got SAS Visual Investigator as a solution. You have SAS anti-money laundering as a solution. And on an older platform of SAS, you also had another solution known as the SAS fraud management. Right now, when you talk about risk management, or if you talk about the IFRS reporting, like IFRS 9 or IFRS 17, then you've got risk modeling based solutions on SAS, and you also have IFRS 9 specific solution and IFRS 17 specific solution. The same thing goes with healthcare and life sciences as well. You have health cohorts as one of the solutions, you have life sciences analytics framework as another solution that works over and above the analytics life cycle. And the classic one relating to marketing is something that goes by the name of customer intelligence 360. Right. So all of these solutions that SAS offers, capabilities that SAS offers, has been positioned over and above the analytics life cycle. So the fact that you can prepare your data, you can build your model, the analysis of it is something that you can push within the solution if you do not already have predefined rules or predefined conditions in order to work with the problem statement at your end. So the moment you talk about security and intelligence, it is not limiting itself to one specific industry. So security and intelligence does not always come up only when you talk about banking and finance, but then you would have a lot of different departments, a lot of different domains that have a layer of analysis relating to fraud detection, right? So you have a lot of regulatory compliances. So, like I said, you have the anti-money laundering rules and regulations. You have counterfeiting of funding of terrorism rules and regulations that have been laid out by different regulatory agencies across different geographies. So each and every company out there, each and every brand out there has to comply with all the rules and regulations that have been put down by that corresponding body, right? Over and above this, if you're looking at certain other domains or certain other industries, if you're talking about telecom, or if you're talking about healthcare or life sciences, or if you are talking about insurance, then fraud detection is very important there, because you would end up having certain scenarios where people would end up trying to cheat you. Correct. So you are not limiting yourself just to the banking and the finance sector, but then each and every sector out there would have its own nature of fraud detect or fraudulent cases. And you would want to put a check and not wait till the time a particular fraud situation occurs for you. Right. So we are going to start off with the anomaly detection part, but before I could begin with this, I'm just going to take a pause. Are there any questions from any of you all here? Any questions? All right, so I request all participants to please mute their microphone. Okay, so we are going to start off trying to understand why is why the very first example that we are going to take up is relating to anomaly detection. Now, before I could begin with a little bit of theory of this, let me introduce the example that we are going to look at, or the data that we are going to look at. Now, the example that we are going to work with is the data set that we are going to take is a fictitious data set. It goes by the name of PaySim. And this is the moment you say it's fictitious, it is basically a simulated data set that has mobile-based payment transactions, right? So this could either be relating to a banking um, company, or it could be relating to just a financial service, or it could also be relating to one of the new quicker payment mechanism, something like a Google Pay or an Apple Pay that you end up looking at. So any kind of a payment transaction that has been carried out onto your mobile handheld device, we are going to analyze that, right? Now, the kind of inputs that you have in the data are a combination of both numerical as well as categorical features, and has details like in terms of what is the type of the transaction that was carried out, what was the amount that was transferred, and the different account numbers of the sender as well as the recipient accounts. Right, so very typical set of inputs where you're just looking at the type of the transaction, the amount that has been transferred, the account numbers of the sender, as well as the recipient accounts. The target, we already have a target column in the data, and the target column is whether the transactions are made by fraudulent agents or not. Now, one of the mechanisms that has been used in order to identify past behavior or to detect whether that particular transaction is fraud or not is in terms of having a transaction that has been carried out beyond $200,000. Okay, so the moment you're looking at a mobile-based payment or a mobile-based transaction that is beyond $200,000, that transaction or the details of the transaction has been flagged as a fraud transaction. Now, not necessary, it has to be the same across different geographies. It can differ from geography to geography, like the threshold amount that I was talking to you about when I was giving you the structuring example, that's going to differ, right? So here we are looking at the threshold amount of being $200,000. Now, in further details for the target, the moment you talk about the fraudulent behavior of these agents, it could be of different types. So here you can have some of the agents where they end up taking control of some of your customer accounts and trying to empty the funds by transferring to another account, or as well as cashing out of the system. Let's say if you cash out of the system, or in case if you transfer from one account to another account, and if you're going to transfer these huge amounts of money, there could be an indication of some kind of a suspicious activity that that corresponding account holder, either at the recipient side or at the sender side, is engaging into misconduct, right? So let me just open up the data for you. So we are going to go ahead and use developing SAS code in order to just understand our data in short, right? So we are just going to write a couple of queries to just visualize. I mean, not visualize in terms of graphs, but just to get an idea. Okay, so the data, I already have it in a library, which is by the name of VI data. The name of my data set is PaySim sample. Now, this is just a sample. The actual data set is a very large data set, but then since here we are just trying to get an understanding as to what kind of models you could actually use in fraud detection, we've taken a very small sample of the original data set. Right, so if I just want to describe what kind of information this data set has, I can just use a very simple condense procedure, point it out towards the data set of my interest. And when I execute the corresponding code, let's just have a look at the output or the nature of our data. So this sample, which is a PaySim sample, has about 127,253 observations, and the number of variables that are available in this corresponding data set are 11. If I scroll down further, I get details in terms of different variables. So some of the variables, the input variables that I have would be the amount of the transaction that is being carried out, the type of the transaction that is being carried out. Then you have the details in terms of from which account did it originate, which destination is it going to, which account is it going to, and you also have the balance details of the old accounts, sorry, the originating accounts as well as the destination accounts, right? So these are some of the columns that I can possibly use as inputs. And I also have one flag variable, which is fraud. Now, this is fraud is being marked as one on the basis of the condition if a particular transaction that has been carried out shoots beyond $200,000. So if I have to understand the rate of a fraud case in my sample, I can just use a simple frequency procedure, point it out towards the data set again, which would be vi data.pay sim sample. To start off with, I will just get a table of my target variable, which is fraud, and go ahead and plug in the run button. So here you do notice out of the entire 127 change variable observations we have, you only have a very small percentage of the observations that are pointing out towards a fraud case, right? So this becomes a rare event for us, and this becomes more of a one class classification problem. And a lot of our traditional predictive modeling techniques will not hold good if we have to try and utilize them in understanding which of the input variables are pointing out towards a fraudulent behavior, right? So this is not even 1% of my sample that is pointing out towards a fraud case. So this is a starting point that we would have to keep in mind. So all our traditional, and bottom line is, the moment you see a one class classification problem, which means basically you have 99% of your data that is pointing out towards not a fraud case, and you have only 0.13% of your data which is actually pointing out to a fraud case. So this becomes a rare event class, and it becomes a one class classification problem. And the moment you identify that, you know for a fact that any of your traditional predictive modeling techniques is something that you would not be able to use if you have to try and understand the behavior of a fraudulent transaction. Now, the second very important thing that I would want to do is, over and above looking at just the fraud rates, I would also want to look at this fraud that has been carried out, or the fraud indicators that have been created of 0 and 1. How do they work in terms of the type of the transaction? Right, so I'm just taking the type of the transaction as well, and I'm going to look at, sorry, there's a spelling mistake there. Yeah, so across the different types of the transactions, I want to try and see if there are very specific types of the transaction where a fraud case has been detected. Right, so here I do notice that, okay, under the cash in type of a transaction, I do not see any fraud cases that have been identified according to the $200,000 logic that has been applied. For debit-based payments also, I do not see any kind of a fraud case identified. For payment also, I do not see any kind of a fraud case that has been identified. So my frauds have been identified only in terms of cash out as well as transfers. Okay, so direct transfers between account to account and a cash out. These are the two places where I do have 82 observations under cash out and 82 observations under transfer that have an indicator of it being a fraud case. So the second very important thing that I would want to do is I would not want to include all types of transactions in my sample before I could begin the analysis. Right now, we could possibly argue saying that, okay, maybe the sample wouldn't have been created appropriately. You've not taken into consideration different types of transactions under cash in, you've not taken into consideration all different types of transactions under debit or payment, and so on and so forth. But keeping all of the assumptions in mind, saying that the samples or the data pre processing activities have been carried out exactly like the way we wanted to have carried out, we are directly getting into the next part wherein we are trying to figure out across cash out and transfers if I can utilize these 82, which is a total of 164 observations, in order to pinpoint an actual fraudulent case. Now, in order for me to do that, I would want to filter this data and I would want to bring in only cash out and transfer based observations. So I can now move on to another application that I have mine, which is build models. And the moment I get into build models, you will notice that it takes you to, if you look at the address bar, it is pointing out towards Model Studio. Even if you look at this blue application bar here, it is pointing out towards Model Studio. So that is the tool that you end up using if you would want to create any of the uh, predictive models or machine learning algorithms. All right, so I'm now going to go ahead and create a new project. So the starting point would be to create a new project, bring in the data of your problem statement. You would then there would be certain pre-processing activities that you would have to carry out in order to keep your data model ready. All right, so I'll just click on the new project button in order to create a new project. I'm going to give it a name of fraud detection demo. Now, there are different types that are available onto Model Studio. So if you have to work with open text data, then, and if you would want to go ahead and look at natural language processing, then you have a project type which is text analytics. If you are working with time series data or sequential data, you would want to build forecasting algorithms or use forecasting algorithms, and you have a type which is known as forecasting. If you're purely working with predictive modeling or machine learning techniques, then you have the very first type, which is data mining and machine learning. So we are going to go ahead and utilize the data mining and machine learning type of project itself. And for the template, I'm not going to select any template here because I want to just use an unsupervised learning technique in order to bifurcate or to identify fraudulent transactions. So the different templates that you have as a part of Model Studio would usually be relating to a predictive modeling or a machine learning pipeline. So it would have certain data pre-processing nodes. It would have, after that, it would have, maybe a logistic regression node. So if I just type in basic template, so here under the basic template for a class-based target, which is more of a categorical variable as my target variable, the pipeline would end up having a data imputation node, it would have a logistic regression node, and it would also have a model comparison node. Now, if you're looking at an interval target, for obvious reasons, you would not be looking at logistic regression, but then you would then look at certain other modeling techniques, and an example in the basic template would just include a linear regression model, right? So there are multiple different templates in case if you do not you're not quite sure as to how you should go about building a predictive model, then you can use these different templates. You have basic templates, you have intermediate templates, you have advanced templates that you can use, and it then just becomes a plug and play in the pipeline that you end up creating. Right. In our case here, I'm going to start off with a blank template because I do not want to use any predictive modeling technique to start off with. For the data, I will click on the browse button and I have to point out towards where my data is residing. So I come to the data sources, I'll get onto the server, and I have my data which is residing in a library pointing out towards my credential. Right, so here you do see CAS user ashwini.reddy at sas.com. So I have stored my data inside a personal library and not as a public library. So if I open up this corresponding path, there are a lot of data that I see here. The data which is of my interest is already loaded onto the memory of my server. One of the things that you need to remember when you work with the Wire platform is that if you would want to explore your data using visual analytics, visualize your data using visual analytics, if you would want to prepare your data with point and click options via Data Studio, you want to build your predictive models, any different tools that you would want to use onto the Wire platform requires your data to be loaded in the memory. And the reason for that is it allows you to have faster processing of your data. It leverages a multiple parallel processing system, and it gives you the optimized mechanism or the optimized technique of not having a higher IO, which is, every now and then picking up observations from your disk, putting onto the memory, working with it, and then pushing it back to the disk. So that time or that CPU consumption that would then come into the picture is minimized to a very large extent onto the Wire platform. Right. So the starting point of working with any kind of a data onto Model Studio is you need to have the data loaded onto the memory. And the way you can identify it is with the small Thunderbolt icon. The Thunderbolt icon points out towards it being an in-memory table. You do see certain other tables here that have a snowflake icon to it. So if I take, say, for example, the PaySim labeled, you notice that this OK button is not highlighted for me. I have to have this table loaded onto the memory, and then only I would be able to utilize it onto my project. So I'm just going to go ahead and select the PaySim sample, and I'll go ahead and click on the OK button. And to start off with, like I said earlier, we are going to look at an unsupervised learning technique such as support vector data description in order to understand the fraudulent behavior in my data. Now, if I would want to go ahead with that, I don't necessarily have to partition my data because there's not going to be any validation that I would want to do. There's not going to be any kind of a testing as well that I would want to do. Right, so under the partition data, by default, SAS is going to partition your data into training, validation, and test. And there are two different methods available, a simple random partitioning or a stratification approach. I'm just going to go ahead and say, do not create a partition variable. So this way, I'm not partitioning my data because I'm not going to use a supervised learning mechanism. I'll click on the save button, and I'll again click on the save button in order to create my project. All right, so the moment the project gets created onto Model Studio, you would have four important tabs that would come up for you. The very first tab is the data tab, where you can get the exact same details that you saw earlier with the help of a condensed procedure. You get the overall details in terms of how many number of columns, how many number of rows do you have in the data set, what are the different variables that are there, what is the type of the variable, what is the role, the predefined role of the variables, how SAS has identified the roles of the variables. You have all of that information that comes up onto the data tab. Here on the data tab, the first time when you create a new project, most probably you would end up getting a warning that ends up saying you must assign a variable with the role of target in order to run a pipeline, right? So you have to pick up one variable, give it a role of a target, and that's when you, whatever nodes that you then end up using in order to build your analysis, you can execute them. Right? So all of that build happens onto the pipelines tab. There are multiple pipelines that you can create here. Here as well, you will see the same warning coming up. As and when you create different models, if you would want to compare those models across different pipelines, like the champion model from each and every pipeline, you want to compare it, then you perform that activity under the pipeline comparison. And then finally, if there are certain insights relating to your data, relating to your pipelines, that is something that you would be able to see under the insights tab. Okay. So starting off, the first thing that we are going to do is from the data tab, we are going to take this is fraud variable, and the role that was designed, the role that has been picked up here is input. We are going to manually change this to a target variable. So I'm just going to select the is fraud variable. And on the right hand side, there are a lot of properties that you can set for any variable that you would have selected. So for the is fraud variable, I'm going to go ahead and change the role from input to target. Once when I do this, the level I'm going to leave it as binary itself. By default, it would end up selecting the higher value as the target event level. But in case if you would want to change this, you just have to click on specify the target event level and then select a value of your choosing. So I'm again going to leave this as one itself, and I'll click on save. Now, similarly, there would be certain variables that you might not want to use in the analysis. Right? So, for example, if you see this is flagged fraud, by default is got rejected. There would be a reason as to why this particular variable has got rejected. You would be also able to see the details as to why the variable has got rejected under the comments. So for the variable is flagged fraud, it's got rejected because it says that the variable is a constant. So you have only one value that's appearing across all the observations in this corresponding data set for the variable which is flagged fraud. Okay, now there are certain other variables. Just as an example, I'm going to show you as to how we are going to go ahead and reject them in order to not utilize them in the analysis. So the first thing that I'm going to do is I'm going to select this is flagged fraud is anyway rejected. Over and above this, I'm going to take the account destination name where the transaction would have been on the recipient's side. So I'm going to reject that. I am also going to reject the type as well as a step. So I don't know what the step variable is. Step could just be a timing of the transaction. Type, we know we would want to manually filter for only cash outs as well as transfer as a transaction type. So over and above that, I do not want to use any other type. So I'm just going to go ahead and reject these three variables. So I can select multiple variables, and on the right hand side under the role, I can just go ahead and say rejected. All right, so you would notice now the role for these three variables have been changed to rejected. Also, the moment we had selected a variable to have a target role, you notice that warning symbol that was appearing on the data tab is no more displayed for you. And if you get into the pipelines here as well, you will not be able to see that warning symbol. Okay. Now, the next thing that I want to do is I want to perform a filtering. And in the filtering, I just want to go ahead and utilize only two types of transactions, which is cash out and transfer. So in order to bring in those filters, I can just right click on the data node. I have an option to add a child node. And I'm going to write a SAS code in order to create my filters. So I'm going to select miscellaneous. I'm going to go ahead and select the SAS code option. And once when I bring in the SAS code node on the right hand side, again, I would be able to set different properties for any node that has been brought in into a pipeline, right? So here again, in order for me to write the SAS code, I just need to click on Open Code Editor. And the filter that I'm going to put is going to be on the output data set. So I would need to write that down under the scoring code. So I'm going to create a variable here. In order to create the variable, I'm going to use a len statement. And I'm going to create a variable which is filter underscore flag. I'll define it as a numeric variable itself. So I'm just going to mention the length to be 8. Following this, I'm just very simply going to write an if then else statement where I'm going to say that if the type of the transaction is equivalent to cash out. So there is a truncation of the values that have happened in the data so that T is not visible in the type. Like we saw in the developed SAS code when we wrote the frequency procedure there. Or I'm saying if the type is equal to a transfer, again, the last R has been cut out. So if it is either equivalent to these two, then we would want to have the filter flag to carry a value of 0. Okay. Else, we would want to have the filter flag to carry a value of 1. All right. Now, this filter flag that we have created as a part of the scoring code, that needs to be defined as a role of filter. And we are going to do that in the training code. Right, so we are going to change the metadata properties of our data set, and we are going to use a predefined macro that we have there, which is dmcas underscore meta change. So this particular macro program is going to change the metadata details of variables that you have within your input data set. Right, so you can also use a metadata change or a metadata update kind of a node, but then since we are anyway using a SAS code here, might as well, you can just achieve it straightforward here. So the 3 different parameters that you plug in would be the name first. So the name of my variable for which I want to change the properties is filter flag. The role, I want to have it as a filter. And subsequently, the level of the variable is very important. And I'm going to mark the level of the variable to be a binary variable. So you do know that it has values of only 0 and 1. So the level is, for obvious reasons, going to stay as binary itself. Now, before I could go ahead and execute this code, I would want to save it. I'll close the SAS code window. I'll right click on the SAS code node. I have 2 options. I can either say run pipeline, or I can just right click on the SAS code node and go ahead and click on the run button. So either of the two is going to run all the nodes that have not been ran previously or any nodes that have undergone changes. It's going to rerun all of them, and then subsequently it's also going to run the node of your choosing. All right, so we get a message here saying that the pipeline has successfully completed. Now, if I just go ahead and right click on the SAS code node and click on the results button, you just get to see the overall properties here in terms of how the filter has worked. If you click on the output data, you can just click on view output data. You can take up only a sample of it. So I'm just going to print about 20%, 20 rows in the output, or have a look at just 20 rows. Yeah. So here you would be able to see under the type you have only the cash outs or the transfers as the transaction types that are coming in. Okay. Over and above this, if I also right click and go ahead and look at the log window, the log window also says here the saying that there are no messages under the errors. There is one warning. The content requested by the URL was not found. So that's something that we can safely ignore. And under the notes, you should also be able to see how many number of observations were written into the output. Right, so you can just have a look at both the log window as well as the results window in order to ensure that your SAS code node has got executed successfully. Now that I have prepared my data, now that I have a limited set of observations that I would want to work on, let's talk a little about the anomaly detection. Right, so anomaly detection is a mechanism, an unsupervised learning mechanism, in order to identify items or events that do not conform to an expected pattern as such. Right, and here you end up looking at items that have or observations that have a very small chance of occurrence. Like, so if you're talking about structural defects or if you're talking about malignant tumors in MRI scans, so the number of people who actually end up having a malignant tumor in an MRI scan from the entire bunch of people who would perform or who would undergo an MRI scan is going to be a very small number. Similarly, there could be hundreds of thousands of transactions that would be carried out in a particular day for one specific bank, but you would not have a lot of them that would be identified as a fraudulent behavior or as a suspicious transaction. Right, so anomaly detection methods come into the place. There are multiple ways to do this. So when you talk about unsupervised detections, you have support vector data descriptions, you have principal component analysis, PCAs, robust PCAs, you have autoencoders, you have a variation of a decision tree known as an isolation forest as well. So across all of these different techniques, the reason why you end up having very specific techniques is, again, like I said, it's a one class classification problem, for the only simple reason being that the actual case or the actual item of that suspicious behavior or that event that you would want to identify that does not follow an expected pattern is going to be a very small number, almost negligible number as compared to your entire population. So similarly, under the supervised detections, you have the entire traditional bunch of it, but they are not going to be helpful in an expanded usage, for the simple reason being that the non-fraudulent behavior would have a heavy hold on terms of identifying, okay, let me just rephrase that. So when you end up having a one class classification problem, when 99% of your observations are pointing out towards expected behavior and just less than 1% is pointing out towards a non-expected behavior, your predictive models or supervised detection techniques would not help you in very clearly trying to identify that rare event. So you would want to combine an unsupervised learning technique with a supervised learning technique and utilize a semi-supervised learning technique such as graph-based techniques that follow the SVDDs in order to clearly identify your fraudulent cases. Right, so when we talk about the SVDD, like I said earlier, it is a one class classification technique. And the moment you talk about one class classification, you're talking about one class being abundant, but the data points relating to the other class are scarce or rather unavailable in nature. So it is inspired by a support vector machine. Support vector machine is a two class classifier technique, but in a support vector machine, you have a hyperplane, and then you are looking at vectors on the hyperplane that can be clearly distinguish behavioral patterns. In an SVDD, here you would not end up having an hyperplane, but you would end up having a radius based hypersphere where if you have a lot of similarities across your observations, they all sit in a particular circle. Anything that sits beyond the boundaries, so your support vectors would end up becoming the boundaries. Anything that sits beyond the boundaries or not having a spherical description of the observations that sit inside the sphere would then end up being considered as your outliers. And those outliers are nothing but the problems or the anomalies or the cases that would then point out towards a fraudulent behavior. All right. So let's look at this example as to it's a very simple approach in how do you go ahead and use your support vector data description onto Model Studio. Okay, so I'm going to come back to Model Studio. We're just going to go ahead and right click the SAS code. Now we would want to continue with the output of the SAS code itself. So under the anomaly detection or any kind of unsupervised learning techniques come under data mining pre-processing category of nodes. You would not term them as a supervised learning again for obvious reasons. It is just trying to identify behaviors from a very technical viewpoint, such as inliers and outliers, right? So you would have a sphere being created. I'm again just repeating in short, you would have a sphere being created. The support vectors would be the boundaries of the spheres. Any kind of point that does not conform to those boundaries, that stand outside the boundaries, would end up being identified as outliers. And it is those outliers that pinpoint or that end up becoming indicators towards fraudulent behavior, right? So under the data mining pre-processing category, we have the anomaly detection node that we're going to go ahead and use. So I'm just going to go ahead and click on this node, and there would be a lot of properties available for this corresponding node onto the right-hand side. Now, certain things that are good to know is in terms of how would you want to work with anomaly detection. A similar problem, so let's consider this anomaly detection to be a similar problem of clustering or a similar problem of um, principal component analysis, where they work best with interval inputs, and class inputs do not really go quite well or hand in hand with an unsupervised learning technique. Right, so although you do have options in terms of working with class inputs as well as interval inputs, what we are going to do is we are not going to include class inputs here, and we do not even have those many categorical variables. So if I just come back to the data, and if I were to just sort the role according to the inputs. So if we look at the inputs, we have the new balances as well as the old balances that have been considered as inputs. And we have amount, which is considered as inputs. We do not have any categorical variables that we are going to specifically use in our analysis, right? Nonetheless, for SVDDs or for anomaly detections, class inputs are a little difficult to work with. So we are not going to include class inputs here. However, I would want to standardize the interval inputs just so that, we don't deal with extreme observations per se. Following this, in case if you have a default value of a kernel bandwidth that you would want to utilize, and if you are familiar or it has been documented somewhere as a standard operating procedure in your organization, saying that this is the kernel bandwidth, the Gaussian kernel bandwidth value that you should be using, then you can specify the bandwidth value here. If not, you have an option to leave this blank, and then SAS will figure out what should be the bandwidth value in order to perform any kind of analysis. We are going to look at the next part, which is the solver options. And under the solver options, we are just going to, for now, go ahead and select include counts and distance reports. The reason why we are going to select this is because we are going to try and understand on the basis of the anomaly fraction. So the default anomaly fraction is 0.01. So on the basis of this anomaly fraction, on the basis of the threshold value, so you end up having r square that ends up being used as a threshold value for the boundary. On the basis of that, we are going to look at how many observations or how many bins of observations have had a set of observations that lie beyond our boundaries, beyond our minimum radius points. On the basis of those classifications, we would also then end up looking at the number of anomalies that have got detected by this node. So that fraction, we are going to keep it as 0.01 itself. So here, what we end up doing is you end up looking at a slightly loose sphere, a slightly bigger sphere, in order to have a very small set of observations being identified as outliers. All right, so I'm just going to go ahead, right click on this anomaly detection, and I'll click on the run button. Now, since our sample size is pretty small here, it's just about 127,000 observations, this should get completed pretty fast. And you do notice that it says that the pipeline run has successfully completed. Now I'm just going to go ahead, right click on the same node, get into the results. And the first thing that we're going to look at is the distance histogram. So here you do notice that on the x-axis, you're measuring the distance bent from the center. And on the left-hand side, you have the percentages of observations. So you have a threshold bin, which is in yellow color. So your threshold bin here is 0.9872 to 0.9885. The threshold being 0. Rounded off to 0.99. So observations that end up having the r square value lesser than 0.99 is what you would end up considering as inliers. So these are your inliers. And do notice that there are these small purple bars. Let me just try and, sorry. So you do notice that there are certain small purple bars out here that are not very big, but then these bars have definitely been created, and these bars are indicating the observations or bins of observations that have a threshold value greater than 0.99. And the fact that they have the values greater than the threshold value of 0.99, it means that it ends up being classified as outliers, and these outliers are your fraudulent behaviors based observations. Okay, so if you look at the anomaly counts, so the number of anomalies that have been identified are about 444 observations, and the percentage of anomalies is 0.80 out of the total number of observations, which is 55,408. Okay, now this has happened because of the threshold r square value of 0.9878. But in case if you want to make your sphere a little bit more tight, then you would have to increase the fraction of your anomalies, right? So if you end up just looking at 444 observations out of this 55,000 observations being identified as fraudulent cases, there could be a possibility where certain exceptional observations that could have been identified as a fraudulent case might not have got detected in this 444 observations. And that could become a cost for us, a huge cost for us, because that fraud would come with a lot of problems. However, in a fraud detection case, I can have more number of false positives or more number of false negatives. That's fine with me. That's fine with me. And the reason why it is fine is because the cost of processing or the cost of investigating a false positive or a false negative is going to be lesser in terms of trying to actually put in a cost to then work on a fraud that has already taken place, right? So there is a trade off, but the trade off is a bare minimalistic trade off. And having said that, in the properties, keeping everything as is, I am just going to go ahead and increase my anomaly fraction. Instead of having 0.01, I increase it to a value of 0.03. Following this, under the scored output role, so I end up getting a couple of things. What I end up getting is in the output is a variable that's going to have an indication of whether that is an anomaly observation or not. So rather than having it as a filter, I'm just going to leave it as an input. And for the distance role, rather than having it as rejected, I'm again going to keep it as an input. So I'm not removing any variable from my analysis. I'm just keeping my output variables as well so that I can get observation wise details in terms of which observation is actually pointing out towards an anomaly or not. So there are two changes that I've made. The output observation, the output variables, I have included it in the data set. And like I said, I can have more number of false cases. The cost of processing or the cost of investigating those false cases are going to be much lesser as compared to the cost involved when a fraud actually occurs, right? So more number of false cases, fine with me. I don't mind it, right? So in order to work with that, I changed the default anomaly fraction from 0.01 to 0.03. Now we'll again go ahead and run the pipeline and have a look at the output that comes from the anomaly detection node. All right, so the run has got completed. Let's just get into the results now. So the fact that you have increased your anomaly proportion, your anomaly fraction to 0.03, you will notice that the sphere reduces and you would have the threshold R square value reducing. Prior to this, it was 0.98 change. Now you do notice it has come down to 0.9625. And there's also another very important property, which is going to be the bandwidth. Yeah, the RBF kernel bandwidth. This also sometimes can undergo a change. So this is a bandwidth that you saw in the properties where you can plug in your own value, or on the basis of empirical evidence in the data, you can also have this value being picked up from SAS by SAS directly, right? So we have left it on SAS itself in order to work on those 55,408 observation with an expected outlier fraction of 0.03. The kernel bandwidth value that ends up being used is 0.709. And bottom line being that the number of anomalies have gone up. So earlier it was around about 400 change. Now the number of anomalies have increased to about 1580 observations. And the only reason this has happened, now this would include more false positives. Okay, that's fine. And we would want to have a situation like that because fraud per se is a very sensitive area and it is something that's not easy for us to detect. So might as well we spend in time, we have our costs, we have our expenses onto investigating even the false positives rather than actually getting into a situation of a fraud. All right. So that was with the SVDD. It's pretty straightforward on Model Studio. How do you go about using it? So you have just another information before we could wrap up with this topic is if you have to do this via code, then you have a procedure that can be used known as the SVDD procedure. Certain parameters or certain options that you would have to set in there could be the kernel bandwidth, the kernel selection method, your output expected outlier fraction. This is like a compulsory selection, or you could also go ahead and use the default value of 0.01 and the optimization tolerance as well. So again, you can stick to using the default value of 0.001, right? So that's with the SVDD, it's one of the common techniques that end up being used in order to detect fraud with the help of an unsupervised learning mechanism. All right, I'm going to take a pause to take up any questions that you all have for me. I'll just go ahead and stop sharing my screen as well. All right, so we are in a good time for a break. Let's proceed to take a 20 minutes break. In case if any of you all do have any questions, please feel free to drop a message in the chat window. We shall regroup at 20 minutes from now. So those of you all who are in India, it is about 10 a.m. So 20 minutes would be 10:20 is when we would be coming back to the session. For rest of you all who have joined outside of India from another country, please time your clock according to 20 minutes from now. Thank you. Have a nice break and please feel free to drop any questions in the chat window. All right. I hope all of you all are back from the break. In case if any of you all do have any doubts or questions, please feel free to unmute and ask, or you can also type it down in the chat window. All right, we are going to move on to the next topic, which is trying to work with the semi-supervised learning technique in order to detect fraudulent cases. Now, the reason why we are going to talk about the semi-supervised learning is that there are certain problems that come up with a one-class classification problem the moment you talk about supervised learning. So a very typical approach for supervised learning is that your data would have past cases that have already occurred. And those past cases, according to the problem statement, would be your target variable. So there are different input variables that could possibly identify the behavior to a specific target. Now, when you talk about fraud detection, or when you talk about image analysis, or even speech recognition for that matter, these are certain areas in which the chances of a target occurring is going to be very rare in nature. So it becomes very expensive or it becomes very difficult in order for you to obtain data that can have the target column also very traditionally in statistics terms known as your labeled data, right? So the moment that combined with the way the volume of data has been increasing nowadays, you no more limit yourself to just using very traditional statistical methods or algorithms to address a particular problem statement. So in today's machine learning algorithms, you can broadly classify your learning techniques into three different areas or three different categories. So you have the very traditional supervised learning, which would be your logistic regression, linear regression, decision trees, neural networks, or certain simple forms of neural networks rather. Along with that, you have your unsupervised learning techniques. And you also have another area, which is reinforcement learning. But let's keep aside reinforcement learning for now, and let's focus on the other two categories that we know and which are commonly used, which are your supervised and the unsupervised learning techniques. So the basic difference that you would have between these two is that under supervised learning, the output data that you would then end up using for the modeling analysis would have a target variable, also known as your labeled data, in which you can learn on the basis of your input variables as to how your targets are working or how your targets are picking up specific values. When you speak about unsupervised learning datasets, unsupervised learning datasets would not have this target column coming into the picture. Now, in terms of the semi-supervised learning, it is that category of learning mechanisms that purely focuses on learning rates. So something that all of you might have looked at when you would have dealt with neural networks during your time. So you have three different types of neural networks, something the very typical ones would be the concurrent neural networks that can be used for image analysis, or just, sorry, not image analysis per se, but then, and then if you're looking at recurrent neural networks. So these are the different types of neural networks that you have out there that can work with image-based data, that can work with text-based data, or that can also work with sequential data, right? Now, these types of neural networks not usually or not necessarily need to have a target, and especially in a classification problem such as image analysis, you might not always end up getting a large number of image files pointing out towards a tumor identification, or pointing out towards a cyst identification, or even a skin rash for that matter. Right? So then with the help of a lot of unlabeled data and a combination of the labeled data, you are learning from the labeled data and trying to apply it to the unlabeled data, right? So it falls between a supervised mechanism as well as an unsupervised mechanism, wherein the semi-supervised learning technique would end up using a very small amount of the labeled data and a large amount of the unlabeled data to train a model. And what would be the goal of this approach to the analysis? The goal would end up being to learn a function that can accurately predict the output variable based on the input variables. So it is pretty much similar to what a supervised learning technique would do. However, unlike your supervised learning, the algorithm ends up being trained on a data set that would contain both the labeled data as well as unlabeled data. Right? So in our case here, we have two sets. The two sets of data. One would end up being the labeled data that has just 430 observations, out of which 130 observation has been marked as it is a fraud case, and 300 observations have been marked as not being a fraud case. So with the help of the labeled data, on the basis of the learning rate, we are going to apply our learning to the unlabeled data. We are going to take a combination of the two, and the unlabeled data has about 5,000 odd observations in it without a target, which is either pointing out towards either 130 being fraud or 300 being not a fraud case. Okay, to put it in one very simple terms, if we have to try and understand the basics of semi-supervised learning, let's take an example where a student is under supervision of a teacher at both home as well as school. Okay, so but then if a student is studying at home, then there might not be a supervision which is coming in from the school side, right? Similarly, if you learn a particular concept in the school which is being taught to a teacher, the teacher might end up giving some homework which would end up applying a similar concept on that, on those problem statements, right? So the classic examples of your semi-supervised learning techniques and very commonly used would end up being a text classification, image classification, and the example that we are going to take, which is anomaly detection. But before we could begin with just looking at a small procedure, so there is a procedure available which is known as the semi-sup learn procedure in SAS wire that can show you how you can use a gamma rate in order to learn information about a combination of labeled and unlabeled data. Before we could do that, there are certain assumptions, like, you already have assumptions for certain supervised learning mechanisms such as linear regression models. You need your data to be normally distributed, right? Similarly, there are also certain assumptions that you need to keep in mind before you apply your semi-supervised learning algorithm onto the data. So the first very important assumption is known as the continuity assumption. And what is a continuity assumption state? It states that the points that are closer to each other are more likely to have the same output label for obvious reasons. So if you are looking at two individuals having similar features or having similar sets of observations related to each of their behavior, then their end behavior is also going to be of the similar kind. Right, so you have that distance measure. If it is lesser between two observations, they fall under the same cluster. So the moment you talk about cluster, you now get into the second assumption, which is a cluster assumption. So under the cluster assumption, you are assuming that the data can be divided into discrete clusters, and points in the same cluster are more likely to again share the same output label. Okay. So the moment you talk about continuity and cluster assumptions, these two are taken from the unsupervised learning mechanisms, and you're always talking about between group variation and within the group variation. The third and the most important assumption would be the manifold assumption. And here you end up saying that the data lie approximately on a manifold of much closer dimension than the original input space, right? So this assumption forms the foundation and allows you to use distances as well as densities in order to check or in order to identify a fraudulent behavior from a non-fraudulent behavior. Okay, so again, here we're just going to take a very simple SAS programming approach in order to show you how it needs to be done. So the first thing that I would have to do is I would have to get my two data sets. I have two data sets. One is the labeled data set and one is the unlabeled data set. I need to get these two data sets loaded onto the memory. And those two data sets are going to have the same set of inputs that we saw earlier. For the label data, you have only 430 observations, where 130 have been marked as fraud cases and 300 of them have been marked as non-fraud cases. The other data set, which is PaySim unlabeled, this particular data set has about 5,000 observations without a labeling as to whether it is a fraud case or not a fraud case. Right. So to start off with, if you notice here onto my CAS user CAS lib, which is a portion of my memory, I have only one data set which was loaded, and that was the one that we used in Model Studio. For me to apply the semi-sup learn procedure, I also need to get these two additional data sets loaded onto the memory. Right, so I'm just going to go ahead and run the CAS util procedure to load these two files onto the memory. And from the two options, which is out cas lib equal to cas user and cas out, which is a dataset name, you do notice that on successful completion of the procedure, you have the two datasets now appearing under my cas user cas lib. I then start working with the semi-sup learn procedure. The full form of it would be semi-supervised learning algorithm. This procedure, the starting point of it is the data option has to point out towards your unlabeled data set, which means a data set that does not include the target variable. Following this, you have the label equal to, which is going to point out towards the data set that has the target variable in it. And I am going to use a learning rate, which is like a gamma rate, in order to learn information from my labeled data set. Once when I specify these options in the proc sup learn statement, I then move on to the next statement, which is the input statement. And here again, because we do not have enough categorical variables to work with, in the input statement, I have taken all the numerical interval based variables. I've taken the amount, I've taken the new balance at the destination, new balance at the origin after the transaction has been carried out. Prior to the transaction being carried out, what was the old balance at the destination of the account and what has been the old balance at the originating account. So I'm going to go ahead and use these 5 variables as my input variable. And all my analysis, I'm going to write it into an output data set by the name of pay sim out. And I'm going to copy all the variables from the input into the output. Now, from my label data set, I also need to make a mention as to which is my target variable. So I know that the target variable is by the name of is fraud. So that's the point which has been written down onto the target statement, right? Now I'll just go ahead and run this corresponding procedure. And just remember one thing here, there's not a lot that you end up doing, but then if you would actually want to test out whether this procedure that you have written down, whether it's really working or not, you have to use a test data set in order to figure out whether it is correctly identified your fraud cases from your non-fraud cases. And again, you would want to have more number of false positives here, so that along with your true positives as well, so that you can focus a little bit more on reducing the frauds. All right, so you just end up getting a mention in terms of the loss rate here, and that's pretty much the output relating to a semi-supervised learning. So just a little bit more information in terms of how does this semi-supervised learning work in the backend. So those of you all who are familiar with clustering analysis or clustering algorithms, you have a clustering algorithm, which is a k nearest neighbors. Okay, so the semi-supervised learning procedure implements the same KNN kernel by finding the top k nearest neighbors for each sample and using them to build, again, a sparse hyperspace kind of an area to calculate a similarity measure. And this similarity measure is going to work on terms of your labeled data. So you're looking at the labeled data being the nodes or the vertices in the graph. And then you have the edges or the links, which ends up being the distances or the similarity measures. So in your unlabeled data, you again start looking at the distances across different observations. Lesser the distance, they all get classified into one cluster that would have a similar output label. All right. So that's just to put it in short as to how you would have the semi-supervised learning algorithm under PROC semi-sup-learn working in order to use a technique to again help you identifying fraud cases from non-fraud cases. All right. We are in a good time to take up any kinds of doubts or questions. Okay. All right. If there are no doubts or questions, we are now going to move on to the next part, which is in terms of looking at how did I decide, or how did some of my observations in my labeled data get marked as a fraud case on the basis of a rule. Okay, so we're going to talk a little bit about how anti-money laundering works, and we're going to take certain scenario-based examples for, again, a fictitious case here, which is, or a fictitious bank, which goes by the name of Orion Star Bank. Now, this Orion Star Bank has a lot of information in terms of customers. Okay, the customers can be domestic customers or it can be international customers as well. Each of these different customers could have accounts. Accounts can be single owned by one particular customer, or accounts can be owned by multiple customers as well. So more of a joint ownership. And these customers carry out a lot of transactions via these different accounts. So we have three major pieces of information with us. One is we have details about our customers. Second, we have details about the accounts that these customers own. And third, we have details about all the transactions that have been carried out of different transaction types. It can be debit, credit, wire-based transactions that these customers have been carrying out over a period of time. Right, so I'm just going to go ahead and initiate a new program file here. So I already have all the data of mine sitting in a library by the name of FSC Core. And just let's have a look at the information across each of these different tables. So I have an account table. And if you just look, there are about 23 columns in this table. The total number of observations that we have is 2,141 observations. And what kind of information that you have? You have the name, the account number, you have the type of the account that is being owned by the account holder. Then what is the registration type? Is it a single account or a joint account? Then following this, there are certain other details in terms of the name of the account. When did the account come into existence? When was it opened with the bank? Is there a closing date or not? So in case of the closing date is pointing out towards 5,999, it means that the account is an active account. Anywhere you see the account status as closed or dormant, especially closed, not dormant, but then if you see the account status as closed, then it means that there would be a corresponding account closure date. Dormant indicator basically means that in case if there's a continued activity that is being identified with that account, if for a specific number of days, for some banks it works on the basis of 3 months. For 3 months, if there has been no transactions that has been carried out in that account, then the dormant indicator becomes yes, otherwise it stays as N itself. Then you have in terms of which corresponding product category, what is the type of the product that is associated to the corresponding account. Then you have certain personal details, like in terms of a tax identification number, mailing details, and you also have an employee indicator, which is pointing out towards whether the account is owned by an employee of my bank or not. Right. So if I would want to utilize this information in order to identify a transaction that has been carried out by a specific account, I would have to do it with the help of my account key. So this is something that would end up getting recorded in the transaction details as well. And that becomes my starting point of the analysis. Now, along with this, if I happen to look at the transaction table, so if I just open up the TXN, which is a transaction table, I start getting a look at all the transaction details of a specific transaction that has been carried out by an account. So if you see here, you have the account key, and the account key becomes a starting point to marry the transaction details to a specific account details. If I'm able to marry it to the account for obvious reasons, I would also be able to marry it to the account holders, which becomes my customers. So for the transaction table, you get to see the date on which the transaction was carried out. Then you have a credit debit indicator, which is an indication of whether it's a credit transaction or a debit transaction, basically money coming in or money going out. Then you have the primary medium of the transaction. Is it a cash transaction? Is it an external transfer wire transaction? So that's the medium. What was the amount of that transaction? What is the secondary medium of the transaction? Mechanism. So there could be a possibility where certain cash transactions are an ATM withdrawal. So you can see that being indicated under the mechanism. Certain transactions can also be carried out by international customers. So you also have an international account indicator, such as one, which is pointing out towards an international transaction, right? So if I have to analyze all these 89,556 transactions that have been carried out, according to the anti-money laundering rules and regulations that you have across different geographies, there has to be a transaction monitoring system in place. And that transaction monitoring system is based on just simple rule-based scenarios. Okay. So for example, there's this person by the name of Charles Pryor. He walks into his bank branch in order to deposit cash of about $12,000. Now, when Charles Pryor walks into the bank branch to deposit this money, the cashier who is sitting there in order to take that money from Charles Pryor ends up making a mention to Charles that, listen, there is a $10,000 threshold or a deposit limit. If you want to deposit cash, at the max, you can deposit 10,000. If you want to deposit more than 10,000, there will be certain documents that are needed. So then Charles Pryor ends up getting a doubt. And what Charles Pryor ends up doing is rather than giving those documents, one important document could probably be a source of income of the 12,000. From where did he get that $12,000? That might be one of the necessary documents. We don't know. I'm just making an assumption saying, yeah, okay, that could possibly be one of the document that would need to be submitted if the amount of deposit is exceeding 10,000. There could also be another possibility where the bank branch refuses to take a deposit beyond 10,000. All right. So then Charles Pryor, what he does is he tries to be a little smart, and instead of going ahead and depositing 10,000 or the entire 12,000, he reduces his amount of deposit to 9,000. Now, me as a cashier, when I notice Charles Pryor doing this, I record the deposit in the system, but at the same time, I also end up raising an alert and I pass it on to one of the investigators. So I go ahead and I mark in the system saying that you might want to investigate this particular customer, you might want to investigate this particular account. So, investigator two, or there could be whichever investigator sitting in the back end, who starts looking at this alert, starts digging deep into the investigation, and on the basis of the analysis, that corresponding investigator can then decide, is it really pointing out towards a fraudulent case? Yes or no? And if it is, or if it is not, on the basis of my analysis, I pass it on to my manager, and my manager then decides if an action has to be taken against this particular account. All right. Now, here what happens is that Charles Pryor could have been doing this multiple times. Now, the first time that Charles Pryor went to the bank branch, tried to deposit 12,000, he figured out that there is a 10,000 deposit threshold. So he ends up depositing 9,000. Subsequently, anytime Charles Pryor goes to the bank, Charles Pryor ends up always depositing amounts less than 10,000, but he starts doing that multiple times, and it's always cash. So when the cashier at the bank branch had ended up raising an alert, the investigator might have chosen to wait for a while and check if Charles Pryor's behaviors are going to continue. So then the investigator suppresses it in the system, and the investigator is working in terms of trying to identify more transactions that Charles Pryor is going to carry out. Now, when the investigator is waiting, we do notice that Charles Pryor is doing this multiple times. It can be an indication of certain kind of an illegal income that Charles Pryor is earning, because of which there is no valid source of income. Charles Pryor is unable to show that, or Charles is trying to evade tax. It could be either of the two, right? So then it starts getting identified as a fraudulent activity. So there could be multiple different rules that you would want to create. And you have different solutions at the SAS end, such as SAS anti-money laundering or SAS visual investigator, that is going to help you create these rules in a very easy, automated, and governed approach. But rather than me showing you how to create those rules and those solutions, I'm going to show you how those if then else rules can be just designed using a simple SAS programming language. So the first kind of scenario that we're taking here is a record level scenario. So what is a record level scenario? You are trying to identify individual transactions that meet a specific condition. Okay, so an example could be a single cash transaction over $10,000. So in the US, you have something known as a currency transaction report that you have to submit. In India, a similar transaction report, a similar currency transaction report is known as a suspicious activity report, which is a SAR. Now, when you talk about a suspicious activity report, or if you talk about a currency transaction report, it has different connotations in different geographies. The limits, the amount limits are again different in different geographies. So here we are looking at a single transaction carried out by an account that is over $10,000. So if I have to just configure this rule in my system, all that I need to do is identify the column which has the amount being recorded. So I know that, okay, that column is amount. Now I would have to do the analysis according to the account key. And I will have to do the analysis for one transaction, which means according to the transaction key. So I can just write a simple program. And here I'm just using a simple SQL program. You can also use a data step. Either of the two are perfectly fine. So what I'll end up doing is I will select the account key and I will select the amount from the FSC core transaction table, and I'll designate it as A. I'm just giving a table alias as A, and I will put down the condition which says that where my single cash transaction should be of an amount greater than 10,000, and very specifically my primary medium, I'm talking about a cash transaction, has to be cash, right? So I have two filters that I would want to put. One, in terms of the amount being greater than 10,000. So I put a filter here. And I will also put a filter on primary medium being cash. Okay. So I'll say where the amount is directly greater than 10,000 and the mechanism or the primary medium of the transaction should be equivalent to cash. So it can either be a cash withdrawal or it could be a cash deposit. All right, so it's a simple code that I have written down where I'm just getting the list of the account key and the amount. Let's also take the transaction date to see when was this transaction carried out. Now, when I execute this code, okay, so there's a mistake. The transaction date column does not exist. It could probably be named using another key. Okay, so the name of the transaction date is actually date key. So let me just change that quickly. Okay, now let me go ahead and execute this code. And let's have a look at the log first to see how many number of observations have come out. Yeah, so your SQL procedure does not really print as to how many number of observations have been identified as the output. So nonetheless, I'm just getting into the results. So you do notice that there are a lot of accounts, or it could be multiple transactions as well. You can sort this according to the account key if you want. There have been transactions that have been over and about $10,000 on different dates. All right. So if I'm looking at a cash transaction report, and if there's a threshold amount of about $10,000 and my primary medium being cash, then for such kind of transactions, there would be some kind of an additional proof that's needed in order to indicate from where is it that you have got that cash. Now I'm just going to jump a little bit. This can bloat your number of transactions that are coming up. There could be a situation where a customer has carried out this transaction maybe just once in his or her lifetime. But I would be interested to see how many times has a person carried out a similar behavior of a transaction. And that is when you start talking about aggregation or cumulating the analysis. So here, I then start looking at another scenario where a transaction of about $10,000 with the primary medium of cash has been carried out, say, multiple times in the past 1 week. Okay, so and then counting the number of days. So I can have different connotations to this. I can very specifically look at cash withdrawals. I can just directly look at any kind of a cash deposit or withdrawal or credit or debit kind of transactions of just $10,000 and a primary medium of cash. I can limit it in terms of a specific time period. I can look at it across a lifetime of the customer. I can choose to do it either ways. So here I'm just taking a very simple example wherein I'm going to say that these transactions of having a single cash transaction over $10,000, a customer should have carried it out multiple times. So how would I go about doing that? So I'm looking at the account key. I would end up taking a count of the date key or the transaction key, one of the two. I'll take a sum of the amount. Okay. Let's also see if that transactions have been carried out multiple times in a given day. So I'm also, okay, let's do that as a part of the next code approach. For now, what we'll do is we are just looking at multiple transaction keys. Yeah. So each transaction can be identified with the help of the transaction key. So I'm looking at counting the transaction keys, summing up the total amount. So I'll say, I'll term this as total amount, and I will term the count of the transaction key as count number of transactions. I'm taking all of this information again from the FSC code.txn table itself, and I have put in the, I'm going to keep the filter as is. But along with this, I am also going to group my analysis. So that's my first level of filter. And I'm going to group my analysis according to the account key. And I'm going to put in those two additional filters where I am, or that one additional filter, uh, where I'm saying that a customer should have done or carried out these transactions of the same nature at least more than 2 times, 2 or 3 times. Right, so I will say count of the transaction key. Let's take, for example, greater than 2. So I'm looking at a repetitive behavior of my customer. Okay. So now when I execute this code, I get a smaller set of customers, a smaller set of accounts. And for each of the account, I can see the how many number of times the transactions were carried out. So I don't have any account that has carried it out twice, but I have accounts that have carried out the similar transaction 10 times. I have accounts that have carried out the transaction, the similar behavior of the transaction 7 times, 6 times. So these are pretty large numbers. Okay. So now further, what I would want to do is now this cash transactions can be of any kind, right? So if I just come back to the transaction table, and if I just go ahead and put in a filter here where I say the primary medium equal to cash. So here itself, I get a huge number of records across the entire 89,000 records. But then when I look at these records, my CDI indicator could either point out towards a debit or it could point out towards a credit. Okay. Now, I would want to look at deposits specifically. So I'm bringing in one more and amount greater than 10,000. So this was our primary filter that we had put where the amount was greater than $10,000 and the primary medium being cash. This was a starting scenario that we were working with. Now what I want to do is now I want to look at specifically cash deposits. Okay, now I want to look at cash deposits that have an amount of greater than 10,000. So that could be possibly an indicator of not having a formal line of work maybe. All right. So what I can do along with this is I bring in one more filter, which is a CDI indicator being exactly equivalent to C. And this limits my transactions for different accounts furthermore. So if I have to just plug in this one more filter, now where I have changed my analysis to look at cash deposits specifically. So I say, and the CDI indicator is equal to C. These results that I've got here, this count, either the total number of accounts should have reduced or the number of transactions should have reduced. One of the two should have reduced. So when I execute the code, you actually notice that none of the two have reduced to, yeah, if I just on a quick look, I don't see anything that has reduced. I'm not digging deep into it. So we for sure know that all these accounts have deposited amounts greater than $10,000 multiple number of times. Then you would also be interested to know the date range. Okay, so then are you, if you're going to further very specifically look at a scenario such as structuring, then you would have to deal with a time period of these transactions being carried out. The time period could be 1 week or it can be 2 weeks, where every alternate day the person is going and depositing $10,000 in the bank. Okay, so that's an indication of structuring. There could be multiple withdrawals. So even multiple withdrawals is an example of structuring of very structured amounts, very specific amounts that are not going to come under the radar of the regulatory authorities. Right. So if you have to identify such kind of structuring cases, not necessarily all of them will always point out towards fraud. It can just be a suspicious activity that a customer is carrying out. Not necessarily it is an indication of counterfeiting of terrorism, not necessarily it is an indication of illegal businesses such as drug peddling, and not necessarily it is an indication of a money laundering. But there are certain rules that have been laid out by different regulatory authorities. On the basis of those rules, you have to configure certain scenarios in order to identify these transactions. So just for these accounts, whatever transactions are totaling to this amount, these transactions over a lifetime of the customer point out towards some kind of a suspicious activity that requires an investigation. If in the investigation it turns out to be an actual fraudulent activity, that is when these cases ends up being marked as fraud. Okay, now here itself you can see in our account, sorry, in our transaction table, we have about 89,000 observations, roughly 89,000 observations. Across 89,000 observations, on the basis of this small aggregating condition, I get only, oh, let's count 1, 2, 3, 4, 5, 7, 8, about 8 accounts with a maximum of 10 transactions. So even if you have to just do the maths, you're looking at only 80 transactions. Okay, so there are 8 accounts, assuming a maximum of 10 transactions per account. They're varying numbers though, but still you end up just looking at, for that one condition, only 80 observations pointing out to just a suspicious activity. So these 80 observations, about roughly 89, sorry, 80 observations divided by 89,000 observations. And if you're just going to look at the percentage of it, you have a very small number which is actually coming up into the picture. So you have a very small percentage of those 89,000 observations or 89,000 transactions that have been carried out, which is pointing out towards suspicious activity. And this is a reason why now, if you go back and think as to what we did in the previous 2 hours, remember that in such a situation, you would not be able to use your traditional mechanisms of analysis. You will have to perform either PCA analysis, or you would have to use isolation forests, or you would have to use some of the complicated mechanisms like the one that we spoke about, which is the SVDD, in order to identify a pattern of the fraudulent behavior. Hence, in the industry, the moment you talk about fraud and analytics, especially if certain sectors have been governed by rules and regulations, then you have to follow through them in order to detect fraud, right? So, classic example would be when it comes to banks, financial institutions, especially banks, where you have voluminous amount of transactions being carried out by different customers that have accounts. They are all governed by anti-money laundering rules and regulations that have been laid out by different regulatory agencies. If you are a financial institution that deals with insurance, as an example, there can be fraud even in terms of claims for a particular insurance policy. So you can have fraudulent claims in automobiles, automobile insurance, you can have it on health claims, you can have it on life claims. Now, in order to take care or in order to identify that, and worst come worst situation, if you are not able to identify a fraudulent claim, then the next thing that you have is different regulatory authorities lay down a capital allocation provisioning. They lay down rules and regulations in terms of how much capital you should be having in order to evade any kind of a risk that comes your way. And one risk, there are multiple types of risk when you talk about insurance or when you talk about banking and financial services, but one of the classic risks that you have is fraud, right? So there are multiple ways in which you try to cut out the bad eggs from the basket right at the starting. So by doing customer profiling, which is again cluster based analysis, segmentation based analysis. So the moment you start looking at demographic analysis, the moment you start looking at customer profiling, the moment you talk about the credit history of a particular customer, these are different ways that you remove the bad eggs at the start itself. That is when you end up deciding if you should be giving a loan, as an example, to the corresponding person, or you end up deciding what should be the interest rate that should be charged. You start looking at whether you should be giving an insurance policy to a specific user, to a specific person. And if your answer turns out to be no there itself, there's no harm in it. You are losing business. I mean, not to a very large extent, there is an opportunity cost which is coming into the picture there. But then you are also trying to not have an increased cost later on in order to fight that particular fraud case. Okay. So it's only because of this reason that only with this one small scenario, we haven't even plugged in a time period. I'm not even putting in a window. If I have to think about the actual structuring definition that has been specified here, where you're talking about cash withdrawals or the count of cash withdrawals only in the past 5 days, there could be a possibility where this number of transactions or these accounts that have been identified to have the suspicious activity will come down even more. So you're looking at a very small number, just a two-digit number across 89,000 observations of transactions that have been carried out with your organization. So trying to use labeled data, trying to use supervised learning mechanisms is not the right way forward in order to identify behavioral patterns. You can use more of the complicated terms such as your concurrent neural networks. You use recurrent neural networks, more of the recurrent neural networks, not concurrent. Use more of the recurrent neural networks in order to try and identify pattern in behavior across a time period. All right, so that was the last bit that I wanted to show you. And when you talk about uh, creating these rule-based systems, you have to take into consideration time periods. You have to take into consideration look back for how many number of days or how many number of periods would you want to do the analysis. How do you want to offset your analysis? Do you want to look at fixed period analysis or rolling period based analysis? These are different parameters that act as guiding principles to you in order to identify specific patterns. Now, you use obviously you would use the regulations and then you have to code them in. And those are your rule-based systems that form the foundation of a SAS solution, such as SAS Visual Investigator or SAS Anti-Money Laundering. All right. So this was the example that we looked at, where we looked at just identifying one particular bad behavior, one particular transaction following a set of rules. And then we are looking at how many times has that particular transaction occurred or carried out by an account over a specific period of time. All right. Um, we have a lot of time for questions. I don't seem to be getting any questions today. So we've reached the end of what I wanted to discuss with you all in terms of fraud analytics. You're looking at two very important parts. Just as a quick revision, you're looking at two very important parts. One is a statistical approach to fraud detection. And anyway, that in order to do that as well, your basis is a rule-based system to identify suspicious transactions or to identify fraudulent behavior. And applicability is across all industries where you deal with cash transactions or money-based transactions. All right, so that's it from my end. So before I could move on to the wrap up, we've got a lot of time to take up any kind of discussions. So please feel free to unmute. You can either contribute in case if there's anything that you want to share with the entire team out here. Please feel free to do that. If you have any questions for me, if you need any information from me, please go ahead and ask. All right, let me give you all some time in order to think over any questions. In the meantime, what I'm going to do is I'm going to go ahead and share certain snaps in the chat window. So like I said earlier, you when it comes to fraud analytics or fraud detection, you have different solutions at the SAS end. So you've got SAS Visual Investigator, anti-money laundering, fraud management, law enforcement, and customer due diligence. Uh, you do have a lot of learning modules. It gives you a good overview as to how these solutions work, how you should be configuring rules, how you should be working with the reports, and as well as the regulatory submissions. So you have two very nice learning paths that have been created. One is SAS Predictive Analytics and Machine Learning, which talks pretty much about what I had showed you all. The two examples that we discussed today has been picked up from the same learning subscription. And you, on the other hand, the last piece that we spoke about, which was the rule-based, the if then else rules conditions, that is also something that's the bread and butter of different solutions that we have at our end. And it automates the whole process, which otherwise you would not be able to do just with the help of writing simple SAS programs. Okay, so the entire list of solutions and the training spirit is something that you can find in the second learning subscription, which is SAS Fraud and Security Intelligence. So I'm just going to go ahead and plug in a copy, a snap of this in the chat window. Y'all can just download this at your end, such that you can refer to it at a later point in time. The other thing that I'm also going to share is the contact person, the contact details of our region heads. So for different countries, we have different region heads who can help you with education details relating to fraud analytics or otherwise. So you can also just reach out to them if you need help in understanding how can you pick up on the knowledge that was discussed today. Right, so that's the second image that I'm just putting it down in the chat window.